Okay, we're going to build on our previous videos, which were about polynomial division, remainder theorem, factor theorem, and so on. And we're going to learn how to solve a polynomial equation beyond quadratic. So this is, we're going to focus, in fact, on a cubic in this one, but this process can be for higher order polynomials as well. So it's going to be a cubic. And we're going to solve this one as an example, and we're going to go through the steps and hopefully explain clearly why we do the steps. Now, the process involves finding a linear factor. Now remember, linear means x to the power 1 is the leading term. So an example of a linear factor might be x minus 2. Alright, because the x to the 1. Another example of a linear factor might be x plus 3, because the leading term is x to the power 1. Okay, so here we go. Just basically the steps. Hopefully you'll see these as we go through. So polynomial equation p of x. When we solve an equation from your previous work, you know that we solve an equation by setting it equal to 0. You might remember that in particular with quadratics. And we do this by factorizing p of x. If it can be factorized, and the ones that we'll give you will be able to be factorized. So we factorize p of x, but it's a different process to some of the factorizing you might have seen with quadratics. But one thing that is the same is once we've factorized it, we then use the null factor law. Remember, when two or more things multiply together to be equal to 0, either the first thing, the second thing, or the third thing equals 0. That's the null factor law you should be familiar with if you're watching this video. To factorize a polynomial, so this is where we link into what we've learnt recently. So what we have to do is follow these steps and find one factor using the remainder and the factor theorems. The previous video was about the remainder and the factor theorem. So what we do is a good idea is to first consider the factors of the constant term of the polynomial. This actually makes it quicker. So in this one, the constant term here is -6. So look at all your factors of -6. Now, a great place to start is with p of 1. So alpha equals 1. In other words, x minus 1. Try that as your first linear factor. And if that one doesn't work, then move on to the other one that involves 1, x plus 1, because that's p of -1. Okay. If you can, then move gradually up to 2 if 2 works with your polynomial. But definitely start with those there. Work from smaller to bigger. Okay. After we found a linear factor, we use our polynomial long division and we find the quotient, which sits on the top of the division line, and then we factorize that quotient if you can. So it might be a quadratic, for example, and you factorize that. Not all quadratics can be factorized, you might recall. And then you go until it's fully factorized. Let's try it. So we're going to try that now on the polynomial I mentioned before. We're going to solve x cubed plus 2x squared minus 5x plus 6 equals 0. So let's define p of x equal to the x cubed plus 2x squared minus 5x minus 6, and let's kick into our division. So factors of the constant term, so it's factors of -6. Start with the smallest ones. Well, 1. Then we could try -1. And then the next one up would be 2 or -2. These are all things that you can multiply with another number to get 6. Okay, so we start there. So I'm going to start with 1. So let alpha equal 1. Okay, so that means we have a linear term of x minus alpha, which would be x minus 1. So we try that first. So basically that means from the factor and the remainder theorem, we've got x minus alpha. So subbing in alpha being 1 from our remainder theorem. Now remember, from the remainder theorem, this will give us the remainder. Now the factor theorem says that if the remainder theorem comes out as 0, it is a perfect factor. Does this come out as 0? Let's have a look. 1 plus 2 is 3, 3 minus 5 is negative 2, negative 2 minus 6 is not 0. Okay, so that's no good. So we move on to the second one. We basically try negative 1. So p of negative 1. So we're letting alpha, try alpha equals negative 1. So p of negative 1. So negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. So we have negative 1 plus 2 plus 5 minus 6. Negative 1 plus 2 is 1, 1 plus 5 is 6, 6 minus 6 is 0. So the remainder theorem gives an answer of 0. The factor theorem says this is a factor. So what is a factor? When alpha equals negative 1. So what does that mean? X minus alpha is x minus negative 1. So that's x plus 1. Alright, so x plus 1 is a factor. Alright, so then we can divide this thing by x plus 1. Okay, so we have x cubed plus x cubed plus 2x squared minus 5x minus 6. Let me check. X cubed plus 2x squared minus 5x minus 6, and we're dividing that by the factor that we just discovered, x plus 1. So we go through and do the division now, and for details about how to do the division, see the previous videos. Okay, so we now need to bring the next one down. So we times that one by x. Subtract. Negative 5 minus x is negative 6. Okay, we need to times x by negative 6 to get negative 6x, so negative or minus 6. And 1 times negative 6 is negative 6, and that comes out as 0. So we have a quotient up there. And we have the divisor there. So we can say, putting that together based on our previous work, therefore we factorized x cubed plus 2x squared minus 5x minus 6 into x plus 1. You can see that there in the turquoise color, and in the yellow x squared plus 6 minus x in the yellow there. Okay, so basically we need to make sure that's fully factorized. So now I'm looking at you, Mr. Quadratic. Okay, are you able to be factorized further? So the x plus 1 is solid. So let's see if we can factorize that. So we need two numbers that multiply together to be -6, and using a decomposition method and add together to be 1. How about +3 and -2? Okay, because 3 plus -2 is 1, and 3 times -2 is -6. So if you want to use the full decomposition method here, you can. So we break it down into +3x, take 2x, -6, and x plus 1, and then we factorize here. Okay, and then x plus 1, and then x minus 2 is a factor, and x plus 3 is a factor. Okay, and then we have our three factors. So to solve it, we set it equal to 0. Null factor law now, as we said at the start of the video. So x plus 1, when x plus 1 equals 0, x equals -1. When x minus 2 equals 0, x equals 2. When x plus 3 equals 0, x equals -3. Therefore, we have solved it for the values of x. There's our three solutions for x.